This comes out of the review preview section for Chapter 5. I don't always do a review preview example in the videos here, but this one's probably worth having a look at. It just says find the intercepts of the following curves. So we're given a whole bunch of various functions here, and the one for this particular question I've chosen here, 1c, says y equals x squared plus 2x minus 3 divided by x squared plus 1. If you want a y-intercept, you let x equal 0. And that's a pretty easy calculation here because you end up with y equals negative 3 over 1, which is negative 3. So if you're graphing this function, which becomes the point later on, you have a point at 0, negative 3, that's actually on that graph. When I go to say what the x-intercepts are, I have to let y equal 0. And in this case, that means I've got 0 equals x squared plus 2x minus 3 over x squared plus 1. A lot of people put too much attention on that denominator. That denominator is kind of irrelevant to this question because, first of all, it never equals 0. And even if it did, that wouldn't be an answer to this question because that wouldn't be a place where y equals 0. You can't divide by 0 anyway. That would look like something else, a non-permissible value, something else on your graph. So really what I'm solving for is when does 0 equal x squared plus 2x minus 3. If you factor that, x plus 3 times x minus 1, so you've got two answers, x equals negative 3 and x equals positive 1. So at negative 3 on the x-axis and positive 1 on the x-axis, you have two more intercepts. And so as far as finding intercepts goes, that's it. And we'll start our curve sketching questions with that. Often, in fact, always try to find whatever intercepts you have. So it's definitely not calculus just yet, but something we still need to correctly draw a curve. The other review preview exercises come out of page 206. The little lead into that starts, page 204, 205. They talk about the symmetry of functions. Now, not all functions have any kind of a symmetry, but we have in this section some functions that are even and some functions that are defined as odd. An even function is one where if you put in negative x, you get the same answer as if you put in x. So a real simple example of an even function would be y equals x squared. If you take negative x and square it, it still gives you x squared. And if you put in 3 and negative 3, you get the same answer. If you put 10 and negative 10, you get the same answer. One reason why they call them even is because all of your, x to the 4, x to the 6, x to the 8 are all even functions. They have symmetry in that they look the same on both sides of the y-axis. It turns out that those aren't the only kind of functions that have even symmetry. If you look at y equals cos x, looks something roughly like this. And it turns out that it gives you the exact same value if you put in a negative angle as the positive angle. So cos of negative x is the same as cosine of x, and so cos of 30 gives you the same answer of cosine of negative 30. You can see how that would be a shortcut. If you knew a graph is symmetrical about the y-axis, if you have half of it, you can draw the other half. Now, odd symmetry is slightly different. If you put in your negative value for x, you don't get the same answer, but you get the negative answer. An example of that is y equals x cubed. The symmetry is a little bit different because as I go up and to the right, the x cubed function looks something like that. As I go down and to the left, I go like this. It has a symmetry about the origin, some people will say. If you put in negative x and cube it, it's the same as having a negative out in front of the x cubed. If you put in negative 2, you get negative 8 as your answer. If you put in positive 2, you get positive 8 as your answer. And so all of your y equals x to the 5th, y equals x to the 7th, y equals x to the 9th, odd functions because of their odd exponents, but even y equals sine x can be considered to be an odd function. As you go up and to the right, you get the same answers, but positive compared to the answers you get as you go down and to the left. And so if you put in negative 30 degrees, for example, you get the negative answer of sine of 30 degrees. So even odd symmetry is something worth checking out. If you don't understand it or have trouble with it, try some exercise on page 206 and ask some questions if you have.